All right, the last thing we're going to look at is called the perpendicular bisector theorem. It says if a point is on the perpendicular bisector of a segment, then it's the same distance from both endpoints. So notice here I have a segment, and because of these tick marks, I can tell that this is a midpoint, and then this line here is a perpendicular bisector because it's going through the midpoint at a 90-degree angle. So this theorem says if I put a point somewhere on the perpendicular bisector, I could put it anywhere, that's just where I'm choosing to put it, it's the same distance from both endpoints. So if I measure how far it is from here to the endpoint on the left, I can see it is about 4 centimeters. Then if I go to the other side and I measure, notice it has the same length. It's also 4 centimeters. And the reason that is because you end up making two congruent triangles. We can prove them. They're congruent by side, 90-degree angle, side. So by side, angle, side, these two triangles would be congruent. So these two lengths are congruent. Okay? It doesn't matter where on that segment you place the point. You could place it kind of low like I did, or I could have placed it way up here at the top, and these would also be the same length. Anywhere along this line, you're going to end up, oh, I managed to go 5 centimeters. Okay? So when I go to this other side, you're going to notice it's also 5 centimeters. Every point anywhere along this line is equidistant to the two endpoints of the bisected segment. Okay? And what that means is if when you draw your perpendicular bisector in, if it intersects the vertex on the opposite side of the triangle, that's going to tell us something about the triangle. Because think about it, if I have a triangle, and I draw in the perpendicular bisector, so if I find the midpoint, and I find that's the midpoint. If I leave that midpoint at a 90-degree angle, and if it goes through the vertex, that's going to tell me something about the whole main triangle, because I know that this point on the bisector has to be equidistant from both ends. So what does that tell me about the whole main triangle? It tells me it has two equal sides. So when my perpendicular bisector intersects a vertex, that tells us that we are going to always have an isosceles triangle. Okay? So again, that's only going to be true if your perpendicular bisector goes through the midpoint. Or sorry, through the vertex. It always goes through the midpoint when it goes through the vertex of the opposite side. Okay? Thank you so much for watching. If you have any questions over anything with perpendicular bisectors and triangles and circumcenters, please make sure you ask during sync time or attend a tutoring session with a teacher. Thank you so much.